So how can we find the inverse of this function? The first thing we need to do is to first identify our output and the input. It turns out that the inverse of the function is by interchanging the x or the input value with the output value. For instance, as for this function that we have, two x plus 3, right? The input here for this main function is x, and the output here is a function. So we are going to replace this with x instead of this function, and replace this with the inverse. That is going to be our inverse function. So with that, we can replace this with x, and this here we can also replace this x with the inverse function, plus 3. So now we can solve for this inverse. We can send the 3 across. We have 2 is equal to x here minus 3, right? So we can divide by 2 here, divide by 2. So the inverse of this function is going to be x minus 3 over 2. So how can we prove that this is the inverse of this function, of the main function, f of x is equal to 2x plus 3? It turns out that in order to prove that this is the inverse of this function, we have to use the output of this inverse function, because this is the output of this inverse function, as the input of our original function. So it's going to be like this, right? We have to substitute into this original function, 2x plus 3, right? So if the result is going to give us x, then that means that the relationship satisfies, which means that if we have a function that takes the inverse as its input, if it satisfies, this function is going to give us x, right? So now we can try to substitute. it into our equation, we have the inverse of this function. We already found that is x minus 3 over 2, right? We set it equal to this equation 2. Since the input here is this value, we are going to substitute that into x here. So we're going to have x minus 3 over 2, right, plus 3. So now we will have now we can try to distribute this. We're going to have 2x minus 6 over 2 plus 3. So now we can divide by 2. 2 here, 1 time, and 2 here, 3 times. So this is going to give us x minus 3 plus 3. So now this and this can cancel, which means that it is equal to x. Since it is equal to x, then it satisfies the condition that the inverse of the function as the input of the original function is equal to x. So that is it. So let's say, for instance, if we have a function, if we have the inverse function, two x plus 3, and we are told that this is the inverse function of this function, three x plus 2. So in order to prove that this is the inverse function of this function, that this is the inverse, this here is the inverse of this function, we should try to prove that it satisfies our condition. The inverse as the input of a function should be equal to x, right? So now we have this. We're going to consider this as the input, right? And substitute it for x in this equation. So we're going to have the main function and using 2x plus 3 as the input, because we are told that this is the inverse of this function. So substituting it into this equation, we're going to have 3 times 2x plus 3 plus 2. If it is not equal to x, then it doesn't satisfy the condition. So now we can distribute. Distributing, we're going to have 6x plus 9 plus 2. So as you can see, 6x plus 11 is not equal to x. So now let us try to get the inverse function of this function. So getting that, we have f of x is equal to 3x plus 2. So again, we can replace the input with the output and the output with the input. So in this case, we're going to replace this with x. Then this 3 here, we are going to replace this x with our inverse function, which is the output plus 2. So we can send this across. We're going to have 3 inverse function is equal to x minus 2. So we can divide this by, oh, there is no minus, by 3. Divide this by 3. So we have the inverse function as x minus 2 over 3. So now we can also prove this to determine that this is the actual inverse function of the original function f of x is equal to 3x plus 2. So now we can substitute this value here for this as a domain. X minus 2 over 3 is equal to 3 x minus 2 over 3 plus 2 plus 2. So we can cancel this and this. We're going to have x minus 2 plus 2. So if we cancel these two, our condition satisfies that the inverse function as an input of the original function will give us x, right? So that is the function and the inverse as an input is equal to x. Alright, so thank you very much for watching this video. I look forward to seeing you in the next video. Bye.